during these 4 to 5 years that we are dealing with IoT. Okay? So,
Perfect. To start, let's take a big shot, an overview of what is IoT. IoT today, I believe, is present in everywhere. So every single piece of physical world that we live, we can embed some IoT devices, right? We can put some sensors on that. And the main idea when we talk about IoT was telemetry and said, oh, I will capture some data, I will capture some information. And now we are moving, we are shifting to another world that we have intelligence on the edge. That I believe today we have the power and the tools to put intelligence everywhere in a small piece of hardware, and we can use this intelligence to change our life, to change our cities, to change our health, environment, and a lot of others.
okay. Everyone says that IoT is easy. Is everyone agrees? So our experience says that it can be easy, but it can be really complicated when you go into the field and you have a lot of other variables. Okay, variables like what kind of device are you using, what kind of architecture are you using, what are the requirements that you need for your IT solution. Usually, there is no one fits for all, like Lord of the Rings, right? So it's really tailored to what you want to do it regarding this. And this is the first misconception that we're starting to see, that, oh, IoT is just, you have your device there, you have your sensor, I plugged in, I collect the data, and that's it. My IoT project is finished. No,
and another big problem, Marcus, is when you develop a device, and most of the companies are now in the first phase that are on R&D and making they start the warming up to IoT projects. The first idea is, let's develop a device. Let's create our own device. So it can be a big mistake, because when we develop a device, we have problems about security, we have problems about production, we have delivery problems, we have retirement problems. So we have a lot of. And now we have on the market some platforms that we have all that we need.
Yeah.
It's just take this system on a modules with connectivity, some of them with connectivity to big cities, and take it together with some software and put it on the line and work with it. Not develop from zero, from scratch. That can be a big problem. And another thing that Marcus told, when you have a development kit, for example, it should be easy. So let's take this data, take a camera, for example, and, oh, it's only acquired the image over here and send it to the cloud. It's okay, it's easy, but it's easy to work with one device. When you have a lot of, when you put it on a building, for example, when you use it to authenticate people to get in some restricted areas, you should have a lot of big issues.
So basically, IoT, it's not only hardware. It's a component of the IoT. It's the device that is collecting the information. Is something that right now, and probably you see yesterday morning, Satya talking about this, we're starting to have compute power on these hardwares. So depending on what you're talking about, it's not only hardware.
Yeah.
As this is one of the big misconceptions that we're seeing on the fields. The other one is it's not only software as well, right?
Yeah. Some of our projects, we never talk about hardware. The hardware already exists. For example, factories. you never change a factory. You never get in on a factory and said, oh, let's change this line of production, all of this. You cannot do this. This is a big problem. You can't say about that because the project will, whatever. You can talk more about that. And the other problem is, it's not only software, because the developers nowadays used to say, oh, IoT is quite simple because there is software in everywhere. If you say to recognize a face, for example, is just do a call on an API and take this API and take the return. And it's not so easy as that, but software is a big part of it. It's a big part, and you have to take a look, and the skills over here is not so simple as the people say, oh, I'm a developer, I can develop in any language. No, it's not about that. You have some constraints that you should see to develop the project. If you are talking about, let's embed some software in a microcontroller, for example, you should have experience on that, because your time to market should be very, very long if you don't have it.
Yeah, and there are some process that you need regarding to take in consideration. One of them is you cannot process all in the cloud. There are a lot of restrictions about this. One of them is, for example, imagine that you have a camera, okay? And I see a lot of these starting projects like this. You have a camera, and then you want to process everything on Azure. Sometimes that it's not possible. There are lots of other constraints. Like one of them is the data that you are collecting. The GDPR is one of the things that doesn't make this, for example, on this scenario, possible. There are a lot of other variables. But the main one is if you need some fast response on site, going to the cloud and come back with the response, there are milliseconds or even seconds that you need between that could be crucial if you need some real time, some validation or some actions.
And you have another variable here is costs. When you say applications near real time, for example, facilities, for example, cameras and identification, like Marcos told, we have a problem that is, if I send it to the cloud, I have to pay for this message. If I return it, I have to pay it again. I have to pay the communication channel. I have to pay a lot of small portions of this life cycle of the data that we are talking. We have to pay about that. And when you think something that we need a short response or near real-time systems, we have to process it on the edge. And this is another component of the IoT projects that we have to take a look. And it's another expertise.
Okay, so you probably are familiar with this slide. This is the architecture of IoT. So basically, three areas. The devices that you have, it's essential. The other one is in the middle, is all the back office, let's call it this way, that where you process all that data and all of that inputs, and then you have the actions that you want to do it regarding that information. This is well discussed. We want just to mention this. There are lots of other variables. For example, I'm not a developer, I'm an IT person, so basically I take care on this stream, all of this on the perspective of IoT. George, it's more an hybrid one, so he can develop, so he can do all of that as well. So the projects, again, it's not only about software development, it's about the integration that you have.
And an important thing over here is that when you were talking about edge on the field, you can take and do all that you can do here. Sometimes you have to do here also. And maybe it should be the same code, but sometimes you have to optimize it over here. So it's another skill that we have to think about it when we start the project.
Yeah. Okay. So let's talk about real life scenarios. So this is the notes from the field. We have several projects. We just bring two because we only have 20 minutes. Okay, we can talk about all other. One of them that is one of the most popular is the smart retail. So the idea over here is we get the cameras. Okay, so when we get the cameras, we get the gateway. So we are collecting the information from the cameras to the gateway. Okay, then we send this to Azure with Azure Functions, with Event Hub and everything else. And then we will use, in this case, we did use the cognitive service to recognize the person. The idea over here is to, on the first prototype, we are collecting a bunch of data, but the importance for this store, for example, was only to see what gender of the person entered to the store, what age, and what is his or her emotion, okay? And the output of this is we will play the playlists accordingly to just improve sales. That was the project, okay? So, but we did collect a lot of other information, or we could collect, but we kind of ignore it, and you can see this. So what we did is you have the store, and on top of the store, we have the camera that we develop, or we use it in this case.
One is these pictures are from our first prototype of this product.
Yeah.
We are running this in some stores in Brazil, and the main problem here was we have all these services on the cloud. We have the cognitive service. It does most of this information for us. Not the name and if she is a buyer or not, and when she returns, but the service can say the emotion, it can say the age, it can say the gender for us. But the problem is, I'm in a small store. I don't have connectivity all the time. I don't have costs to pay for this streaming, to send this image to the cloud every time. So we had to take it from the cloud and put it on the edge. Yeah. We have an information on the cloud that we use the cognitive services for the first time, just for the first time. If she gets in on the store or something new gets in on the store, we take the information and then we put it on the field and use it every time. So this kind of skills is that we are forging every day in our company to develop more fast the device, because now we have all in the clouds. Yeah. But the problem is, how can I fit it to our client? Yeah. Because we have the problem that is costs. Cost is the biggest.
And in this scenario, for example, we have a very minor software development. On the other scenario that we're talking in a few moments, we had way more developed. Just to give you an idea that an IoT project, it's not only about development software, or in this case, develop the code. You can do it with very, right now, good service that, the cognitive service that we use in Microsoft. It is ready. We're just using the APIs to send the information and get the information from. So that's why we bring these two projects, okay? The next one, it's the vehicle monitoring. Can you?
Yeah. On this guy over here, we had a problem. That is, first of all, when you say that you will be monitor a truck, you are talking about put it on the roads, and on the roads we have problems with connectivity. We have all the problems that, for example, we have a bunch of sensors inside the vehicle. This one over here is a TPMS that we put on the back of the vehicle. And our main problem over here is all that I have to do over here. And my cost should be very, very low. It's not only a tracking. We have some information over here that I have to know the weight of the truck. I have to know some other informations about autonomy and pressure of the tires. For example, we have a lot of other information that we have to combine it and say, oh, I'm good on the road or not. Why it should stops here and it doesn't. So this is the main idea over here.
And when we developed this sensor, because we did develop this hardware for this project, we can use a lot of things. We can use the pressure of the pressure of the tires. We can use all the information that we are collecting from that gateway, from the motor and from the vehicle himself, like what is the consumption of diesel, what is all of that information that we can grab as well, besides other things like the motion, GPS, if the doors are open, if not, if they open the back. So the usage of this device, for example, could be tremendous. So they can use for a lot of other things and a lot of other practice. In this case, it was for a truck, but we are starting to see a lot of this applicable to other solutions. This one, because of that gateway and all of that communication, we develop a little bit more. Do you want to talk about that?
We have to use more hardware on this project than software, because the main problem over here was the communication with the sensors along the truck. That was our biggest problem, because if we have some sending from this guy to the main cabin over here, and we have another truck beside it, we have interference. So on this guy over here, the problem was how to develop hardware. So because that we are talking about IoT is not only hardware or only software or only cloud. Every project is different, right?
Yeah.
Guys, I guess this is it. Let's open to
some
questions.
Yeah. Don't forget to do the evaluation. We want to come back next year with with more exciting sessions. So let's open to some questions.
No?
No? Okay. Yes.
What is the radio from the device to the cloud?
Sorry?
Is it Wi-Fi or LoRa, or what is the technology from the
In which one?
Yes.
In which project? Or in the truck?
In this one?
Here is a GSM.
GSM?
Yeah, GSM. We try to use the narrow band. We try to use narrow band, but narrow band is not available in all roads in Brazil. So this is a case that we're running in Brazil. And for this guy, we developed a communication module that we can change it for another one. We are now prospecting on the market a new project to use the same idea, but in another scenario that we will use LoRa, because we have a constraint area.
And even on this, even using GSM, one of the things that we discover is not all the coverage of the GSM is always good. So we have some kind of gray areas, shadows, and completely out of service areas that when we give that to the sensor and to communicate to Azure, that was some kind of problem. So in this case, what we did is we did all the compute in this guy, all the compute that we want to do it, and when he gets the signal, when he can establish the communication, then if anything happens, then we send the alarms and then we send everything.
We have a data logger inside it and Bluetooth that communicates with the cell phone of the driver. And we said, oh, we do not have communication. So just check it. And we are now thinking something about use the Bluetooth as a tethering to get into the cloud. Anyone?
Yeah, how about the backend? The Azure side, is it public or private cloud or?
Sorry.
The Azure, is it public or private cloud?
Public. We are using all services, all in service.
Yeah.
Here we do the ingestion, use the IoT hub over here. Some of the information we pass through in a blob storage, and then we process using the Azure functions and Event Grid to just see the telemetry of the sensors, not the data.
Okay.
Another one? No? Guys, thank you very much for coming.
Okay. Thank you.